Hi. So in our previous video, I introduced integration with trigonometric signs, logarithm signs, and also exponential signs. And in this video, we would like to just go further in solving more questions. So right immediately, I will start solving more questions. So let's take a question. I have this in my book. Let's say we are told to integrate tan square x dx, tan square x dx. So let me write that very well. Tan square x dx. We're asking to integrate this tan square x dx. Now, how do we do that? First of all, there is no direct transformation for the integral of tan square x. So what do? We have to first of all break this down using trig identities. Now I can break tan because I know that when you write tan can be written as what? Sine over cos, right? So if I have tan x, I can write that as sine x over cos x, and therefore tan square x will be like writing what? Sine square x over cos square x. Now remember, we are still on integration, so I put integral of this dx. But what about sine squares cos squares? There's also no transformation for integrating it. So what do I do again? I can still transform this even the more, and transforming this the more, I can bring in plus or minus 1, which is still the same thing. It's like saying sine square x over cos square x plus 1 minus 1. And when I solve this side separately, I have that this will give me what? Sine square x plus, now I can find, sorry, let me wipe this off. I can find the LCM. The LCM is actually what? Cos square x, and cos squares dividing cos squares multiplying sine squares will give us sine square x. Cos squares dividing the LCM, the denominator here is 1, dividing 1 will give you cos square x, multiplying 1 will again give us what? Plus cos square x, and then minus 1 outside. Now when we solve this, we know that sine squares plus cos squares according to trig identities will give us what? 1 over cos square x minus 1. And remember, we are still on integration. I actually kind of forgot. So we have this, and everything is still on the x, and everything is still on the x. So we have all this in dx. So when we solve this part, now look at this. 1 over cos squares can be written in trig identity as what? Sec square x, and then we have minus 1 all in the x. Okay, so let's continue. So what about sec squares? I know that in integration we have we can integrate sec square x. So let's look at it again from our book. We know that integral of sec square x dx will give us what? Tan x. So what do? We come down and then we do that. So we come here and then we have that the integral. Remember, let's first break it up. We break it up by writing sec square x dx minus 1. Actually, my 1 is still going to remain the same, so I can just take it off and just continue by putting dx. And then integral of sec square x dx will give us what? Tan x. And then integral of the x will give us what? Minus x. Remember, we've done that in our previous video in integration, so you can check out that video in the introduction to integration. We did all these parts of just integrating basic things like integral of the x. So you would have, if you follow the video, I believe you understand what I'm doing here. So what again did we do next? We then finally do what? Put in our constant k, and then we are done. Okay, so that's it really. Remember, we first of all broke down tan square x because we found out that there was no way to integrate tan square x on its own. We had to first break it down to something that was recognizable in our integral function, and we know that sec square x, integrating sec squares in an integral function is recognizable. Therefore, we had to bring it down to that value that was recognizable. Is that okay? So if peradventure sine squares over cos squares like we had here was recognizable, then we would have just stopped there and integrated straight away. But since we know that it was this that was recognizable, then we had to work with this. And this is the limitation of integration. In integration, you have to work with recognizable terms, but in differentiation, from anything you can just start differentiating. It's actually better with differentiation. So integration has a lot of hurdles you have to understand, you have to walk past through. So that's why you need to put in more effort in integration than I think you might put in differentiation. Okay, so let's take one last question, and I might be able to call it, what do we call it, since I don't know if it's day or night in your own side. So I might just say, let's call it, okay, day. I think I'll still go with that, a day. Okay, so this is the last question. We have that if we're told to integrate exponential x minus sec x tan x all dx. Okay, so let's integrate this. Now in integrating this one, what do we have? We have that we can break them down separately. So here will be what? Exponential x dx minus sec x tan x ds. So let's go back to our trig sines integration and see if there's anything that is like sec x dx. Okay, yes, look at it here. We have sec x tan x, right? So this is why I say you have to be very conversant with all these trig manipulations when it comes to integration and differentiation. So when we integrate sec x tan x, what do we have? We have what? Just only sec x, right? So we come here and then we do that. So it's actually very easy once you just know the transformations. So integral of exponential x already we know is what? Exponential x. And then minus integral of sec x tan x from what we've seen is what? Sec x. And then what do we put? We put our constants. I think we should just take one more. I know I promised to stop here, but let's just take one more. I'm still fired up for one more question. So one more question, going. If we're asked to integrate x plus cos x, okay, this should be very simple. So if we have to integrate this, so we have that this is with respect to what? Dx. So integrating this, we have that integral of, we can break this down to two simple values. So x dx plus what? Cos x, integral of cos x dx. So integral of x will be what? It will be x squared over 2. Remember, this is how you integrate. If you still do not remember integration, please go back to the video we've done on integration and catch up on that. And the integral of cos x is what? Is what? Sine x. Remember, putting your what? Constant k. And that's all. That's how simple it can be when you understand your transformations in integration. Okay, so catch you up on the next videos where we might continue solving more questions on trig, sines, trigonometry, logarithm, and exponentials concerning integration, or we might just go on to the next topic under integration. Okay, so see you in the next video.